Respected Sir, ma'am, my partner and I will be presenting a research paper titled Deep Learning Based Forecasting in Stock Market with Big Data Analytics. The paper was published by IEEE in 2019 by a group of scientists in Turkey.
For an investor, the most important task is to analyze the movement of the stock and make accurate decisions. So basically, an investor makes just two types of analysis. First one, technical analysis, where predictions are made on the past behavior of the stock. The second one, fundamental analysis, where the prediction of the stock prices are made on the economic, environmental, political, and other statistical factors. In order to consider all these factors, the system needs to constantly learn and predict prices. So for the prediction, we can use a machine learning model. The main goal of machine learning is detecting, sensing, and learning situation as humans, or at times even better than humans. Deep learning is a kind of machine learning used which learns by experience and classifies the task directly from the data. Deep learning uses neural networks to gain human-like learning and decision making. The recurrent neural network, or RNN, which is an important deep learning model, proves to be useful in our time series data of stock prices. Also, LSTM, or long short term memory, is most successful RNN architecture. Hence, we use LSTM for our experiment.
So every investor wants to predict or forecast the financial time series data like stock action. This can be achieved using the growing literature in this field. Various forecasting approaches like A trader system have also been formulated. This A trader system is a model which makes trading decisions in the forex market. It was earlier based on multi-layer perceptron, that is MLP model, which used the function of sigmoid activation and backpropagation learning algorithm. But its result was not satisfactory and hence was replaced by a CNN, that is convolutional neural network based model, which resulted in the best error rate. With rapid growth of internet and computer technologies, the thickness of trading in the stock market increased in seconds. For example, in some researches, the dataset used is a real-time dataset with high-frequency data, taking into account changes in milliseconds. With the use of this property, either the size of dataset or the requested execution time changes. As the number of data which are generated every second is increasing rapidly, some authors implemented a deep neural network system, and the data set consists of tick by tick, that is TBT data, where one tick corresponds to one activity. It could be a transaction, a bid, or ask price, or any other activity. Approximately 14 million data points per day have been used for the system. Therefore, high computation power is necessary for predictions in real time. Most of the studies focused on using DNNs for estimation as they overcome the problem of exponentially diluting the error while passing through hidden layers, which is the main problem of backpropagation algorithm. In fact, the best available DNN has an accuracy of 66%. Therefore, the importance of selection of appropriate algorithm is emphasized. Next slide. Moving on to methodology, the proposed solution involves three parts: selecting the data set, RNN, that is the model that our solution is based upon, LSTM, an additional layer for dealing with an issue observed in RNNs. So starting with selecting the data set, the data in this work consists of the full historical daily price and volume data for all US based stocks trading on NYSE, NASDAQ, and NYSE MKT, ranging from January to 1968 to April 9, 2018. There are a totally 12,648 trading days. The last 300 days were not processed and were kept for testing. The sample size was not considered large enough for calling it big data. However, the evaluation of the data presented in this work shows that this is enough to get a sufficiently accurate solution with deep learning algorithms. In this data set, we have 5 features. The features are date, open, close, low, and high. Moving on to RNNs. RNNs are used to model sequential data, that is, in our case, stock action, that is input and output prices. The reason that they are called repetitive is that they perform the same task over and over for each element of the array. They have a memory which collects data about what has already been calculated. Below is the basic diagram for an RNN network, RNN model. So moving on to LSTMs, that is long short-term memory. So RNNs are not able to memorize the data for a long time. Since the length of time series, the complexity of this problem is increasing. To overcome this problem of vanishing and exploring gradient, LSTMs are used. Next slide. LSTM layers have their own neurons which store the previous time's data. In the training process, data are stored in memory will be shaped. In this way, even the old data interacts with the new data and creates a network structure that produces more effective results.
Yeah, so the price forecasting model is implemented in Python using the Keras library and TensorFlow for the backend. The close feature is used as a target value that we want to evaluate the performance of our forecasting model. So we implement the stock market forecasting in Python, and the forecasting is analyzed by calculating the root mean square error by using the given formula. So in the graph, the blue lines represent the actual prices of the stock and the orange lines depicts the forecasted prices. The forecasting is done by the RNN model, which is trained by learning from the first 12,000 rows and applied to the final 300 rows to obtain this graph. This graph depicts the accuracy of the RNN model, where the root mean square error value is removed by comparing the real stock price, stock data and the predicted values. Conclusion: it is believed that the movement of stock prices is random and predicting the prices is very challenging due to the non-linearity of the financial time series. But yet we successfully apply the LSTM network to the dataset of the NYSE stocks, where it dynamically captures the details and predicts efficiently. Using the model and using this model, we come to an root mean square error value of 0.04, which is accepted in the real world, and hence it is a successful forecasting model for stock prices.
So yeah, this model can be extended by adding new features for making more accurate predictions. Additionally, some parameter values can be set by using some optimization algorithms to increase the efficiency of the system. Also, visualization tools can be developed to display or run the deep learning models on various stocks. So that was our research paper, and these are the resources with which we used. Thank you.
Thank you.